Okay, out there in the vast emptiness of space, there are monsters. And I'm not talking sci-fi movie monsters. I'm talking about monsters made of physics. These things are regions of space-time so twisted, so completely warped, that they literally eat light. And once you're in their grasp, there's no getting out. So today, we're going on a little safari to hunt down the most dangerous game in the entire universe.
So what are these cosmic beasts patrolling the silent darkness between the stars? Well, you already know, right? They're black holes. And the part that should really give you chills, they are 100% real.
And we know because in 2019, humanity basically stared into the abyss, and the abyss stared right back. This isn't an artist's impression. It's not a simulation. This is the first actual picture of a black hole's shadow. It's a prison for light itself. And that glowing ring, that's the last scream of superheated matter being ripped to shreds. So, how in the world do you even begin to hunt for a monster that's completely invisible and literally eats light for breakfast? Well, here's the trick. You don't look for the monster itself, you look for the trail of chaos it leaves behind.
I mean, that's the whole challenge, right? A black hole doesn't give off any light, it doesn't reflect any light, and that's how we see pretty much everything else. So you can't just point a telescope and snap a picture. No, you have to be clever. You have to look for the havoc it's causing in its neighborhood.
And that basically gives astronomers two main ways to hunt them down. First, you can just watch. You look for its insane gravity yanking other things around, like stars and gas. Or, second, you can actually listen for the sound of two of them crashing into each other, an event so violent it makes the entire universe ring like a bell. For example, by watching the stars at the very center of our own Milky Way, astronomers saw something wild. These stars were whipping around a single dark point in space at unbelievable speeds. The only thing that could have that much gravitational pull had to be a supermassive black hole. We call it Sagittarius A star, and yep, it's the monster hiding in our own cosmic backyard. Now, the other way is to listen. Einstein figured out that when really massive things move around violently, they literally shake the fabric of space-time, sending out these ripples called gravitational waves. You can think of it like the universe's own subwoofer.
And this is what that sounds like. In 2015, the LIGO Observatory picked up this signal. That's not a picture, it's a sound wave, basically converted into data. That little chirp you see? That is the literal sound of two black holes a billion light years from here, spiraling into each other and merging into one. An event that shook the fabric of reality itself.
Okay, so we know how to find them. Now, what are we actually looking at when we see one? Let's, dissect one of these monsters from a very, very safe distance.
The crazy part is that all that bright, glowing stuff we see in the pictures, none of it comes from the black hole itself. It comes from its last meal. This thing is called the accretion disk. It's a screaming hot, brilliant disk of gas and dust being torn apart and heated to millions of degrees by friction as it spirals down to its doom. But not everything goes down the drain. Some of that material gets tangled up in these incredibly powerful magnetic fields and gets shot away from the black hole's poles. These are called relativistic jets. We're talking about blazing beams of particles getting fired out into space at nearly the speed of light, sometimes for millions of light years. It's unbelievable. Now, the key to really wrapping your head around all of this is that a black hole doesn't just pull on things with gravity. It fundamentally breaks reality. Einstein showed us that its mass creates such a deep dent in the fabric of space-time that even light, which always travels in a straight line, has its path bent when it passes by.
And this is the truly mind-bending result. See that galaxy in the background? It's not actually curved like that. The black hole's gravity is acting like a giant cosmic funhouse mirror, warping and distorting the light from whatever is behind it. This effect is called gravitational lensing, and it's one of the most powerful proofs we have of general relativity.
All right, we've watched from afar. Now for the truly wild part of the journey. Let's get a little closer. Let's creep up to the very edge of the abyss itself.
This is the event horizon. It's not a solid surface you can touch or anything. It's a boundary. It's a line in space-time. And here's the crucial thing. Once you cross it, The speed you need to go to get away, the escape velocity, is faster than the speed of light. And since nothing can break that cosmic speed limit, escape is literally impossible. It's the ultimate one-way ticket.
I absolutely love this analogy from the physicist Andrew Hamilton. Don't think about falling into a black hole like you're being pulled. Instead, imagine you're in a canoe caught in a waterfall where space-time itself is flowing into the center faster than light can paddle upstream. Once you go over that edge, you have to go down. There's no other direction.
And this is where reality just completely splits in two. For us, watching from way back here, if we saw an astronaut fall in, they would just seem to slow down as they got closer. Their image would get redder, dimmer, until they looked like they were frozen on the edge for all eternity. But for that astronaut, their watch would tick normally. They'd just sail right past that point of no return without even noticing it. It's a paradox.
Well, there's no turning back now. We've crossed the boundary. So what kind of horrors are waiting for us on this final journey to the center?
I mean, that's the big question, isn't it? The trip past the point of no return as well. It's short, and it's incredibly violent. The laws of physics that we know and love start to get very, very weird.
The first thing you'd experience is a lovely little process called spaghettification. See, the tidal forces are so insane that the gravity pulling on your feet would be way, way stronger than the gravity pulling on your head. So you'd get stretched vertically and squeezed horizontally. Basically, you'd be pulled apart, atom by atom, into a long, thin noodle of plasma.
And that noodle of plasma only has one place to go: the singularity. This is the heart of the beast. It's a region with zero volume and infinite density, where all the matter that's ever fallen in gets crushed down to nothing. And right there, our understanding of physics, of space, of time, it all just ends. It's where reality itself hits a full stop.
So, the journey ends at a singularity, crushed out of existence. Or does it? It turns out the story of black holes has one last, completely unbelievable plot twist.
See, the legendary Stephen Hawking came along and basically rewrote the rules. He figured out that black holes aren't these perfect, inescapable prisons after all. Because of some really bizarre quantum effects happening right at the edge of the event horizon, they leak. They leak a tiny, tiny trickle of radiation. We call it Hawking radiation, and it means they are slowly, very slowly, losing mass and energy. They can evaporate.
But just how slowly are we talking? Well, for a black hole with the same mass as our sun, it would take 10 to the power of 64 years to evaporate completely. That number is so big, it's basically meaningless. It's astronomically longer than the entire current age of the universe. They are basically the last embers that will finally die out in the cold, dark end of everything.
So the next time you're outside on a clear night and you look up at the stars, just remember what's lurking in the blackness between them. These invisible beasts are out there, silently tearing stars apart, warping the fabric of reality, and rewriting the very laws of physics.